Hello everybody and welcome back. Professor O'Hara here with questions 21 through 24 on our 2016 midterm. Alright, so question 21, the limit as x goes to 3 from above, arctan, EO. So this is one of those questions, I've done a one or two in class, where you sort of have to reason your way through it. X is approaching 3 from above, so that's sort of values like 3.1 or 3.01. And then we just slowly build up and try and figure out what this function is doing. So x, what happens to x? Well, first we'd multiply it by -1. And so we'll be approaching -3, but from above or below? Well, if I negate each of these, we'll be approaching 3 from below. Okay. So 3 minus x, we'll add 3 to both sides, we'll be approaching 0 from below. So this is kind of key for the next step. E over 3 minus x is e over values that are very, very small and negative. Now, e is positive. Positive over a negative is going to be negative. A nice constant value being split into more and more parts, all of smaller and smaller sizes. A nice constant number divided by a very, very small number is a very, very big number. So we reason we should be heading to negative infinity. And what happens to arctan if we plug in something that's getting very, very big from the negative side? Well, really quickly, remember what the graph of arctan looks like. As we head this way, we head to one of our two horizontal asymptotes. It'll be -π/2. Specifically, it'll be -π/2 from above, but we're at the end of the question, so we don't actually care about that. And our answer is D. All right, 22. Using the definition of the derivative of f of x equals 4 over x simplifies to... Alright, we have a whole bunch of sort of first principles derivatives here. And they all look like they're the x, or not x, h goes to 0 kind. Well, I know my function, so we can just plug it in. Now, this doesn't look like, oops, not H. This doesn't look like any of my below answers, but that's okay. We can start simplifying. Let's get a common denominator for our fractions down below. Or not down below, up on top. What am I saying? And we'll leave the H down below. Alright, so we'll have 4x minus 4x plus h all over x times x plus h. 4x and minus 4x will cancel out, and we'll be left with just minus 4h on top. Now this h and this h will cancel out, and it'll look like minus 4 over x times x plus h. And that looks a little more like our answers. That's going to be A. All right. So here we go. Question 23. The limit as x tends to 0 of sine x plus 2 over x to the 4. Okay. So what have we got going on here? So the sine, and there's x's on the bottom, it makes me think one of two things. So when I see signs in limits that look a little off, look a little weird, this limit as x goes to 0 makes me think that maybe we're looking at sine x over x, which we remember is 1. That's one of the nice limits we've done in class. So is there a way to sort of tweak this knowledge to get something like this? We can think about it for a little while. The other thing I think when I see sine in here, especially because we haven't seen it so far on this test, would be something like squeeze theorem, or one of the limit laws that involve inequalities. So I know for a fact sine x is between 1 and -1. If I add 2, which we do on top, I'll get sine x plus 2 is between 1 and 3. So if I divide all of these by x to the 4, we're looking at something like that. Now, if this were heading towards infinity, for example, well, this one goes to 0 and this one goes to 0, so by squeeze, we'd sort of be forced to have this middle part go to 0. But we're not looking at a limit as x goes to infinity. We're looking at a limit as x goes to 0. And so we're not going to be doing a squeeze theorem. What we're going to do is point out that, well, 1 over x to the 4 as x goes to 0, it just keeps getting bigger and bigger and bigger and bigger. It tends to infinity. It's just really, really big positive numbers. And what have we just shown? Well, the thing that we're interested in studying, as x goes to 0, it must be getting bigger than 1 over x to the 4. And since that one gets so big it goes to infinity, the limit of this function must be getting even bigger and must also go to infinity. Or possibly something is tweaked and it does not exist, but I don't see d and e as a possible answer. So functions that are bigger, strictly bigger than another one, must have bigger limits. Well, you can't get bigger than infinity, so there we go. E. All right. So the last one for this group of 4, question number 24. The domain of the function f of x and its derivative respectively are. Okay. So, it's kind of interesting. When I look at my possible answers, none of the domains for the function are the same. Of course, they've done this whole none of the above trick, so I do have to do all the work. All right, so what functions or what values can I plug into the root function? Well, anything greater than or equal to 0. So I need x squared minus 9 to be greater than or equal to 0. Okay, so x squared needs to be greater than or equal to 9. So I just need to plug in values in for x that are greater than, in absolute value, 3, greater than or equal to. Okay, so x could be less than or equal to negative 3, because think of something like negative 4. Negative 4 squared is greater than 9. Or the x values could be greater than or equal to 3. So that would, to me, suggest that C is our answer. It definitely rules out A, B, and D. But, of course, this pesky E, maybe they've written the wrong domain here, and the answer is E. Sometimes the answer is none of the above or all of the above for things. So let's take the derivative. All right, so it might be easier to write this as x squared minus 9 to the 1/2. And then we can use the chain rule. The half comes down. X squared minus 9 goes to the minus 1/2. And then we multiply by the derivative of the inside function, so 2x. And so we will get this 2 and this 2 will cancel out. X over the square root of x squared minus 9. Remember, the 1/2 makes it a root, and the minus means we put it in the denominator. So where is this function defined? Well, they seem to, if C is the right answer, they seem to suggest the same values, but you can't have minus 3 or 3. And that makes sense. You know, plug in minus 3, you'll get minus 3 on top, but you'll get the square root of 9 minus 9, or 0, and you'll get minus 3 over 0. Well, that can't happen. So, yeah, C is our answer. All right, so we've got, I think, 8 questions to go. Up next will be 25 through 28. Feel free to join me for those. And in the meantime, have a wonderful day.